Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of stack, that is nothing but next greater element to the right. So before moving on to this question, if you guys are new to our YouTube channel, then please do consider subscribing our YouTube channel. So without wasting time, let's try to understand the question. So in this question, we are provided with an array, and array have some of the elements. Okay, so for each element of an array, we need to tell on its greater element on the right hand side. Okay, so let me take this. Okay, wait, let me take this array onto the whiteboard to understand the question. Okay, hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of stack, that is nothing but next greater element to the right. Okay, so if you guys are new to our YouTube channel, then please do consider subscribing our YouTube channel, and let's move on to the question without wasting the time. Okay, so just to understand the question, let me take this array onto my whiteboard. So we are provided with this array. Okay, and what we need to do in this question is that for each element of the array, we need to tell its immediate greater element that lies on the right hand side. Means the element which is greater than this 5 on the right hand side is not, or greater than this 2 on the right hand side is nothing but 5. So I can say that the element which is greater than 2 is nothing but 5. The next greater element on the right is nothing but, for the 2 is nothing but 5. Similarly, the immediate greater element which is lies on the right hand side for the 5 is nothing but 9. So the next greater element of the right for 5 is 9. Similarly, for this 9, the next greater element is nothing but 12. Why? Just because just because after 9, 3 will come, 1 will come, and both of these numbers are smaller than the 9. So the immediate next greater element is nothing but 12. So for this 9, 12 will come, and for this 3, again 12 will come, just because its immediate next greater element is nothing but 12. So here, okay, wait, let me create some space. Okay, otherwise it will be more congested. Now it will be fine. So for this 9, the value was 12. Okay, again for this 3 also the value was 12. For this one was value was 12. Now for this 12, next greater element greater than this value on the right hand side. Here you can see on the right hand side the values after this element is nothing but 6, 7, 6, 8 and 7, and both of these three values are smaller than the current element. So I can say that the next greater element on the right hand side, it doesn't exist, it doesn't have any element. So what I'll do, I will just print -1 or store -1 in that case. Now for the 6, the next greater element on the right hand side is nothing but 8, which is this. Similarly for this 8, there is no next greater element on the right hand side. So what I'll do, I'll just add -1 here. And for this 7, as 7 is the extreme most rightmost position, is lying at the extreme most or the rightmost position. So as it is the rightmost value, so and there are no more values on the right hand side than this value, so its next greater element is nothing but -1, and we need to print this in the output console. I hope you get it what we need to do in this question. The hint for this question is that use the stack. Try to use the stack and try to solve this question by yourself. Pause this video right now and then watch the solution part. Okay, so let's try to understand the solution approach of this question. Okay, so my intuition will be same. Here also I will use the stack. So let me create a stack, and based on the stack I will perform some task. Okay, now the first thing is that how will I use the stack to get the solution of this question. So the first thing is that I will start the traversal of my array. and based on those traversal I'll perform some tasks. But this time I'm doing the traversal in a reverse order, means I will start accessing from the extreme most position to the 0th position, means I'll start traversing from the 7. Okay, now you might be thinking that why I am start my traversal has started my traversal from the 7, why I'm not accessing it from 2. It is just because I don't know the answer of 2, means if I randomly get any of the array, I don't know the answer of the first element, which is the greater element on the right hand side. But yeah, I can see that I know, means whatever the array I get, I know that the rightmost position element don't have any of the greater element to its right. Just because it is the rightmost element, it's -1 is always the rightmost greater element to its right. Okay, so I know that the answer of 7 is nothing but -1, but I don't know what is the answer of 2. So each time I'll start traversing traversing the array from the right hand side. So what I'll do, I'll just push that element 7 into my stack. Okay, wait, push that element 7 into my stack and add -1 as an answer to the answer array. Okay, so this is the first case. Now let me tell you one more thing, is that flow of execution. Like during the traversal, what will be a flow of execution? So we perform some task repeatedly. What will be those tasks? During each traversal, we just took an element from the array. Obviously, we always took. Okay, so the element which we took, we compared it with the top of a stack. Okay, why we compare it with the top of a stack? Because there is some significance. Let's try to understand what is the significance. The significance is this: whenever we compare the element from the top of a stack, it says means within the stack, actually only the greater elements consist. Okay, on the right hand side. So it says that if the element from the array is greater than the element from the top of the stack, it says that yeah, I am the greatest element till now, because there is no greater element than me on the right hand side, means my answer is -1. But if we get some element greater than top of a stack, means if I get some element, sorry, if I get some element on the top of stack which is greater than the value from the array, it says that no, there is some element which is greater than me on the right hand side, and that value is nothing but top of a stack. Okay, so our execution process will be nothing but each time we get some value, we get some value from array. Okay, and the second point is that this will be first point. We compare that value with the top of stack TOS. I'm writing it as TOS. Okay, now moving forward, what will be our other cases? If the value is greater than top of stack, if the value is greater than top of stack and the value is less than top of stack, we perform some operations. Okay, what will be those operations? We will figure it out soon, but we perform some operation, and the last step is nothing but the value which I'm accessing right now, which on which I'm working right now, just push that element again back to the stack. Why I'm pushing it back to the stack? Just because when we move forward to the left hand side, there might be chances that the element which I'm accessing right now might be the greatest element on the right hand side for some other element which are currently not have been executed till now. Okay, so I will push to the stack. So these will be my cases. Okay, let's try to understand how we will encounter these cases and what are the basic steps which we have not discussed till now. So we have already pushed 7 into the stack. Now I reach to the 8. I check, I compare. So value from the array, the value from the array is nothing but 8. Now compare with top of a stack. So compare 8 with the top of stack. Here I come to know that 8 is greater than top of a stack. So as we come to the moment we come to know that the value is greater than the top of stack, we just do nothing, push the element from a top of a stack. So we are going to push this, pop the element from a top of stack. Okay, I just get a little confused, so it was not push, it was actually pop. Okay, so we pop that element from a top of a stack, and here you can see that there are no more elements that is left into the stack. So what we'll do, as the stack size is empty, it means that there is no element that lies on the right hand side which is greater than the current executing element. So for this 8, we just write -1, okay, into the answer array. And at last step, that is the pushing the current element. So we again push this 8 into the stack. Now again, we reach to the 6. We move to the 6 and we compare the 6 with the top of a stack. Okay. The moment we compare 6 with the top of stack, okay, we come to know that no, this time value is smaller than the top of stack. As the value is smaller than top of stack, what we do, we just don't pop any element from the stack. We just take this value from the top of stack and add into my answer array, just because it says that for this 6, the value which is greater on the right hand side is nothing but a top of stack. So I will add this 8 into my answer array, so my answer array get updated. And the last step is nothing but pushing the current executing element, which is nothing but 6. So I will add the 6 into my stack again. Now the next element is 12. Okay, for this 12 also I will perform the same type of task. Value from the array is 12. Compare it with the top of stack. Top of stack is just half of it, that is nothing but 6. So what I will need to do, as value is greater than the top of stack, what I need to do, I just need to pop all the elements. Why all the elements? Just because there is no greater element which lies in the stack. Actually, we need to pop only those elements which are actually smaller than the current executing element. So here you can see at first we pop this 6 and again we compare with top of stack, and here we come to note 8 is also smaller than value, so we pop this 8 also. Okay, now we come to know that, yeah, here we come to know that there is no element which is greater than this value lies within our stack. So what we do, 12 will also say that yeah, there is no elements which is greater than me that lies on the right hand side. So what we will do, we just print add -1 into the answer array for it. And the last step is nothing but pushing that element again to our stack. So we push 12 again into our array. Now we again iterate, we access this 1, we come to know that yeah, 1 is smaller than 12, that is the top of stack. So we'll just do nothing, just take this 12, add to our answer array, and push this 1 back into our stack. Okay, this is nothing but this fifth step. We keep on iterating, we reach to this 3, we perform same type of task, we compare it with the top of stack, we come to know top of stack is nothing but a smaller value. So as the top of stack is smaller, we need to pop all those elements which are smaller than the current executing element. So we pop this 1. After popping this 1, we compare it with 12, but we come to know that now the top of stack is nothing but greater than the current executing element. So we pop, we just take that value and add it to my answer array. And the fifth step is nothing but adding the value to my stack. So now what value get added? The 3 get added. Now again we reach to this 9, we compare it top of stack, 3 smaller than 9. What we'll do, we just pop this 3. Okay, this 3 get popped out from the stack, and we compare. Okay, again after 3, 9 get compared with 12, but 9 come to know that no, the top of stack is greater than. So we just do nothing, we just print this 12. Okay, so we just print this 12 for this 9, and now push the 9 again back into my stack. Okay, now again our iterator move to this 5. The moment we reach to this 5, we compare it top of stack, that no, this time, yeah, so this time 5 is also the top 5 is smaller than top of stack, which is nothing but 9. So what we do, we just take this 9 and add it to my answer array. We push this 5 into the stack. Okay, now again we compare, our iterator reaches to this 2, we compare it top of stack, 5 is greater than 2, we add it to our answer array, and as a last we get this type of answer as our largest, means we get this array as our largest greater element to the right. Okay, so I hope you get it, that how do we execute this how do we solve this question, how do we execute this approach. Okay, so I hope you get the intuition behind this question. Now what we are going to do, we are just going to write the code of this question. And after writing the code, we try to examine that how this solution which I've explained right now is of order of 1 time complexity. Okay, so this is the Pepcoding portal. Okay, so we need to write the code in a Python in this with means we need to complete this function, that is a solve array2. Okay, this is a solve function and it is taking a parameter of array2. So the first thing which we do is that we create a new list. Why we are creating a new list? This new list will will help will behave like a stack. Okay, no, actually this list, the first list which we create is the answer array, which stores all our answer. Okay, let me create it. 0 into length of array2. Okay, now we are going to create a second list which now behave like a stack. Okay, now let me initialize the first value of this answer array is -1 and need to push something into my stack list, that is array of 2 and -1. That is the last element. Okay, now what we'll do, we'll iterate over the array from the last till the 0. So for I in range, okay, range length of array2 -2 -1 Okay, why we are writing this? Just because we need to iterate in a reverse order, that's why I'm writing it like this. Okay, one more thing is that means this was our first case. What was our first case? First case was accessing each element from the array from the reverse direction, and we are doing it. Now what was our second case? Second case was compare it with the top of a stack. So if the value which currently executing element from the array is greater than the top of stack, what we need to do, we just need to remove all those elements from a stack which are actually smaller than the current executing element. So for that I need to create a loop while length of stack is greater than 0 and stack -1 is less than equals to array 2 of I. Okay, if this is the case, I just need to pop the element from stack pop. Otherwise what I need to do, otherwise I need to check means after this loop I need to check both of the cases. What are these cases now? The first case which is left is what if the element on the top of stack is greater than the current executing element. We have not handled that case also. And one more case that comes now is that what we will do if the stack size is -1, means if the stack size is empty. So if the stack size is empty, this case is nothing, means the currently executing element is the largest element till now, means there is no greatest element on the right hand side. Okay, and this is the case we will handle easy. Now the second case is that okay, so let me write it and then we discuss it. You will get it soon. If length of stack is 2, sorry, if length of stack is 0, in this is the case, what we'll do, array of I equals to -1. Array of I equals to -1. Otherwise what we'll do, else what we'll do, array of I equals to, it was not AR, it was AI. A of I equals to stack of I. So what this what is this else part? Else part says that we know that we have removed only those elements which are actually smaller than the top of a stack. But if we get which are actually smaller than the currently executing element, but on the top of stack we get some element. After popping some of the elements, we get some element on the top of stack which are actually greater than the currently executing element. So we just need to add that element into our answer array. So I'm doing the same, means after popping some of the elements, if I get some after popping some of the elements, if I get an element which is actually greater than the top which is actually greater than the currently executing element, so I just need to add it to my answer array. Or this case, this else part actually handles both of the two condition. Means after popping some of the element, this case is also handled by this else part. And one more case, which was what if we don't pop any of the element, means the element on the top of stack is actually the greatest element, the greater element than the currently executing element. So it handles both of the case. In both of the cases, what we need to do, the element at the top of stack, we need to add it to our answer array. So we are adding it to our answer array. Okay, and the last thing which is left is nothing but adding to our stack, that is st.append. Each element, that is the currently executing element, need to be get added to our stack. Array 2 of I. Array 2 of I. Okay. And the last thing is that return array. RETURN, return array. So this is the code. I hope you get it. Now we are going to run it and then try to examine that how this code is of order of n time complexity. Okay. So before understanding, let me try to run it. So here we get the accurate answer. Let's try to submit it. So yeah, we get the correct answer. Okay, let me take some of the code and then we try to analyze what this code does and how this code will be of order of n time complexity. For that, I will take this function, whole function, okay, onto my whiteboard. Okay, so you might be thinking that here we have created a stack. Okay, we have created a stack, and within that stack we are pushing an element, popping an element using this while loop under this for loop. So you might be thinking that we are performing two operate as we are iterating over with the two loops. It is order of n square time complexity, order of n square. But what if I'll say that no, it is not order of n square, it is of order of n time complexity, just because the second loop, the inner loop, which will this will not get executed each time. It will execute some of the based on some of the condition. Let's try to understand. What if we encounter the case like this? Here means our elements are like this, are this. So what we are doing, each time we are starting iterating from the extreme-most position. So at first we executed, then for this the greatest element is nothing but, okay, so yeah, it is the greatest element. Okay, so the greatest element on the right hand side for this element is nothing but its right one, which is already in the stack. We do nothing, just add that element to our answer array and we again push this element to the stack. So it get added into the stack, this get added into the stack, this get added into the stack. So you can see that for these four elements we have not performed even a single pop operation, but the moment we reach to this fifth element, this is the greatest element of the whole array. Okay, so it removes all those elements from the stack, and after removing it, add -1 to our answer array and it also get added into the stack. Okay, so now means after this four elements, this fifth element perform the pop operation. So you can see this pop operation is actually not get executed for each and every element. It is get executed based on some of the it will get executed or get triggered by only some of the elements of the array. Similarly, this element get added into the stack, this element get added into the stack, this added into the stack, this added into the stack, this added into the stack, and now no more pop operation. What if there will be like this element? So there may be a possibility that it will perform two pop operation to remove this and this and this, and this element that is after popping these two elements, the element which will be at the top of stack will now become the answer. Okay, I hope you get it, that how it is working. So what will be so means why we are so confident that it is of order of n, just because we know that that pop operation is not performed for each element. And one more thing is that each element is get added onto the stack. Okay, Means if an element is not added onto the stack, then definitely it can't be popped out from the stack. So each element is added into the stack only once, and each element is get popped out from the stack only once. Each element means each element or even a single element can't be pushed out or popped out once from in a stack at a certain point of time. Not at a certain point of time. Throughout the whole traversal, a single element can't be pushed or popped twice from a stack. So I can say, as each element is accessing the stack only once, so it means it is of order of n operation. Okay, I hope you get it what I try to explain you. If you like this video, if you get the content of this video, please hit the like button, subscribe to our YouTube channel, and please share this video with your friends. Okay, so we'll meet in the next video. Till then, stay safe, stay healthy.